don't worry. Okay, it's 20 past. That means I ought to talk about stuff now. So, hello. There's a link to my website in the event that anyone has any interest in speaking to me again. There's links to my Twitter and all the rest of it. So if at the end of this you have questions, at least one's about programming. My mum still has the rest of those questions. She's been pondering those for the last 40 years. But yeah, feel free to reach out. So, getting going. Briefly about me, I'm not going to go through all of this. I've been in IT an awfully long time now. It's coming on 2 decades. I really am that old. I've worked in a whole load of different sectors. I've done government and made sure that you folks all pay your taxes. I've done manufacturing, retail. These days, I was briefly one of those contractors that your mum used to warn you about. And these days, I work for Muller, as in Corner. I am told at some point I'll be given some free yogurt, but it hasn't materialized yet. So, Liam, when he watches this video later. But anyway, that's enough about me. This is my program of events. I like films, so I have a program of events, you see. And I'm going with the slightly inaccurately named 6 W's. Who, what, where, when, why, and how of functional programming. That's my structure for my talk. So first off, who is it? These are a couple of individuals who are significant to the history of functional programming. One of them is a developer. See if you can guess which one. This gentleman, though, is a mathematician. His name is Alonzo Church. He's significant to us for a couple of reasons, mostly down to this lotto down here, which I'm not going to pretend I entirely understand, because I am not a mathematician. Caveat going in, I am not a mathematician. But here we go. It's an arrow. This is a shorthand way of describing a function in mathematics. It's an arrow function. There you go, thanks to him. And over here, that's the Greek letter lambda, which denotes a parameter, hence lambda expression. That's where they come from. This was from the 1950s as well. So this man is Haskell Curry, who has no fewer than 3 programming languages named after him, including, rather famously, Haskell. And this is one of his other contributions here. This is an example of currying. Don't worry about that at the moment, but he wrote maths papers which serve as an awful lot of the underpinning of functional programming. But, could this be? Possibly. Yes, it is. This is John McCarthy, who created arguably the first functional programming language, Lisp, in the 1960s. That is a bit of Lisp over there. I don't know what that does either. Apparently Lisp still has its fans. Apparently it's pretty wild. Apparently you can do incredible things like rewriting enumerables as you go or something. I don't know. But in any case, 1960s, and that's how far back it goes. So what is it? Not. Well, the main point of those last few slides is it is not new. In fact, functional programming in some senses predates object-oriented. It dates back to maths papers, which were written largely in the 50s, but I once wasted a Sunday, if you can call it that, trying to trace how far back that particular rabbit hole really goes. And a lot of the very first work was late 1800s. So it's really flippin' old. It is not the latest trendy JavaScript framework. It is not the latest whatever in the development environment. It is really old. It predates Microsoft. It predates most programming languages you're likely to have ever used. It is not a language, in fact. It's a paradigm. Now, what's a paradigm? Well, a paradigm is a style of programming. If you want a metaphor, then take a guitar. With a guitar, you may play many styles of music on. You could play rock, you could play pop, you could play country and western if you have no soul. But you get the idea. It is a style of programming, not in and of itself a language. And it is not imperative. Now, imperative is the common alternative paradigm. There are, in fact, again, this is one of those rabbit holes I went into. There are actually lots and lots of paradigms. But the two biggies, well, the two big families of them are imperative and declarative. Imperative is your object-oriented coding, and it is not like that. Imperative code is very concerned with the very precise order of operations. Start here, go here, loop around like this, go here. That's an imperative approach. Declarative programming is what functional programming belongs to. The rather more familiar form of declarative programming to you folks is probably SQL. SQL is declarative. If you think about it, you're not concerned with the order of operations in TSQL or whichever other flavor. You tend to write select and then maybe some joins, some where, an order by, maybe a group by. Is that order actually the order of execution? No, it's not. Quite often, the select's the last thing that's run. Not always, but often. You get the idea. With declarative, we are not concerned with the order of operations. We are more concerned with describing what we want and then largely leaving the environment to worry about the precise way it goes about them. It's not the solution to all of your problems. It will not make coffee in the morning. I have tried this. It does not work. But I would argue it is the solution to many of them. Nor is it difficult. And that's one of the other ones that gets chucked at functional programming, that it's difficult. It's not. It's not difficult at all. In fact, there are fewer things to learn in functional programming compared to object-oriented. If you don't believe me, go and find a non-technical member of your family and try and explain object orientation to them. Try. It'll take you a lot longer than you think. You've probably just been doing this for a while. Most of the folks that I have encountered who are the keenest to adopt functional are often folks who are new to the business, who may be fresh out of university, who simply haven't spent that time getting used to the object-oriented paradigm. And the folks who tend to be the most resistant are often those who spend an awfully long time in object-oriented and don't really want to shift gears and do something entirely different. But I would still argue that if you were choosing fresh, then this is probably the easier of the two options you've got. There we go. And what actually is it? Well, here's all of the properties of functional programming. Some of these have scary names, but none of them are actually all that hard. It's declarative. Already talked about that. So, as I say, we are not concerned with the order of operations. We are simply describing and letting the machine get on with it. It uses immutability, which basically means that once a variable has been set, you may not change it or any of its properties ever again. Basically, treat everything as a const. Everything, or read-only, or whatever, and all its properties. You can't change it. Done. So, stop using lists, basically, and a few other things too. I'll get on to that. Higher order functions, funky name, not really very hard. You've probably been doing it if you've done C# for any amount of time for a while, and that is variables passed around either as the parameter to a function or as the return from a function. So, Linq. If you've done an arrow function in Linq, that's what it is. Functions, not statements. So, statements, what are those? Statements are things which do not actually return anything. So, for each, if, while, we don't use them. So, this is programming without those structures. Those are imperative structures. Referential transparency, also called pure functions. So, this is the idea that given the same set of parameters, a function will always return the same result, no matter what. No matter the life of the universe, no matter the state of the system, excepting that you turn the computer off. Other than that, given these parameters, you will always get this result. It's called a referential transparency because effectively you can just switch the reference of the function with the parameters for the actual value or something. But anyway, recursion. Are we all good on recursion? Good. Going to be a tough talk for you otherwise. Pattern matching. I used to have to explain this, but I don't these days. Since I have been doing this talk, and I've been doing this talk for about 4 or 5 years now, that's pretty much become a thing in C#, and this is good. If anyone has played with the switch expressions, which are there since, about C# 6, 7, I think, that's pattern matching, and every single version of C# that has been that's come out has had more pattern matching in, even down to C# 11. It gave us the new, as everyone's seen, the list matching. It's our new one. That's pretty cool. There is still further probably to go on it, and there is something called active patterns, which we may or may not get. But anyway, pattern matching is definitely an amazing feature, and it's there in C# for us now. It's stateless. There's no concept of state. Object-oriented code typically goes by the idea that you have a state object we will do a thing, and the state object will sit there, and the thing will periodically ping the state and update it, get it, update it, get it. That's not a concept in functional programming. We don't have a state. If anybody has messed with React and has played with Redux, that's roughly the idea of what we go with. It's what you have is a state which exists for the length of the life of a function, effectively, and you change it by having a function which takes the old state and an instruction and then creates new state. So rather than a single state object, we have basically a series of them that exist for a moment and are constantly sort of disappearing and coming about in a new form. That's it. Monads, you say. Those are the ones that tend to make people's ears bleed if you try to explain to them. There's a talk by Douglas Crockford where he says the curse of the monad is that once you gain the ability to understand it, you lose the ability to explain it. So I shan't. And not difficult. I hope you'll agree by the end of the talk. So where is it? Well, it can go anywhere, and I will probably get into trouble over some of the things I say if there's any pure functional programming folks in the crowd today, but it can go anywhere, it can do anything, but there are places where it is happiest and a better fit if you're having to compromise. Well, these are the languages for a start that you can use it. So there's the pure functional language, or pure Ra. I don't think all of these are necessarily entirely pure, but certainly Haskell is. Erlang's a biggie, and Elm. I don't know if anyone's used RabbitMQ. I think that was Erlang. So I believe that is done with functional programming. And the claim of these languages, the functional ones, is that with some of them that once you actually get the thing to compile and run, nothing will bring it down. Like it's rock solid and can't be defeated, wrought off. And that might well be true. Now we're not entirely going to get that in C#, but I would argue that we're moving closer to that goal by adopting this approach. And I'll show you how later. As the hybrid languages, well, C# is a hybrid language. It is a stated intention of the Microsoft team that they will support both paradigms. I mean, it's true that right at the beginning it was object-oriented only, but these days we're getting close to having a 50-50 split. So you can just about program in whichever paradigm you like. There are some fuzzy edges around which you'll have to compromise, but by and large, we can do most of it. And that's probably something that will always continue with time. Mads Torgersen is a fan of functional programming, and as far as I'm aware, he intends to continue this trend. And on top of that, you've also got the F# guys. F# is the functional language inside .NET, and quite often they will request something for the intermediate language, and since they compile to the same intermediate language, there's a good chance that we in the C# world will benefit from that too. So it's probably a process that's not going to end anytime soon. I have not yet seen much in the way of a spec for C# 12, but I am anticipating there'll probably be something for us in C# 12 as well. And yes, there's F# and JavaScript. Well, JavaScript supports everything because JavaScript is everything except when it isn't. Because everything in JavaScript is everything except when it isn't, except when it's an array, except when it's a function, except when it's not a number or something. I don't know. Because it's the Wild West of programming and it does everything. JavaScript does functional programming far better than we ever could hope. And I have other talks on this subject. Check out Ramda.js if you want to see some really wild JavaScript. So when? Again, it can go everywhere, it can do anything, but these are the things it's the most happy at doing, as it were. Data processing, that is, take data from this form, turn it into this, it likes doing that. Concurrent systems, meaning you've got lots of things running in parallel because there's no state. If there's no state, you tend not to get resource contention issues, and you'll tend to have a happier result. So if you're interested in stuff like serverless functions or feeding off the same queue or anything of that sort, then functional programming tends to support you very well. High criticality, because in general, functional programming is more robust than the object-oriented alternatives. So if it's very important to you that this go up and not come down, you might want to start adopting more functional programming techniques. And serverless, that's kind of ties back to the idea of the concurrent systems. If you are interested in the serverless route again, this is probably some of the things you want to think about. When is it not? Now, once again, I want to check my exits, but it can do these things. It can indeed. But Functional programming is predicated on the idea that it is built up of functions which are pure, that is, no side effects, nothing is happening except data comes in and out. So these are places where you have to make compromises in order to let it happen. There are all sorts of options out there. I know certainly Haskell has a monad-based system for dealing with these, but this is where compromises are necessary. So UI is one, because there is nothing more impure than a human being. External interaction with other systems. You don't know what's going to happen when your HTTP request goes out. Who knows what will happen as it goes down the wire, and it may not necessarily be your fault. It probably is, though. And I/O, same sort of idea. So you can, but again, a compromise is necessary. The metaphor I use is that if you look at a shadow, there are plenty around here if you care to look at one, there are two parts to any shadow. There is the dark, solid part in the middle, that's the umbra, and the grey, fuzzy bit around the edge, that is the penumbra. And I'm learning drawing, I know there's more than two, there's like 12, but two for the purposes of this metaphor. But that solid bit in the middle is what I think of as the functional part of the system. I make that as solidly functional as I can, as much of the system as I can, and the places where I have to compromise, I make as small as possible and push to the fringes of the system where I worry about them less. Now, the big all-important question, why? Why should I even care? It is concise. Now, you don't always get that talked up as a reason for the functional programming being a good idea, but I really like it. It is more concise. It's often up to about half the size, or depending, of the amount of code written for an object-oriented alternative. I am incredibly lazy, and as such, I like typing less stuff. And it's not only more concise, but also it is more descriptive, in part because it has been compacted down so small. So it is usually easier to tell what on earth a function is doing, because there's not all this code noise in the way, which is your loops and all this, and your code structure that exists to actually deliver your result. With functional programming, we don't have any of that, so we can just write a quick few lines and get on with it. Yeah, readable, there we go. Extremely testable. Now, that is one that comes up a lot, and a lot of people like this for. It is. Again, going back to the idea of pure functions, you tend to get incredibly consistent, reliable results with functional code. So it's very easy to unit test. Strictly speaking, in a pure functional environment, you shouldn't even have dependency injection and all sorts, but in C# world, frankly, we do. But still, it will tend to get you better results in a testing scenario. Enables concurrency, we've discussed that before, more robust, kind of talked about that, and it's fun. I think it's fun. And hopefully, again, you guys will agree by the end of this. So, here is a bit of very much non-functional code. What does that do? You've got 5 seconds. Nope, see, it's not that easy, is it? And what that's actually trying to do is we are taking a CSV file, and we're going to start up a list. We are going to loop, and inside the loop, we are going to do various things. We're going to do some parsing. We're going to do a bit of filtering, and that's all fine. But there's a lot of lines of code to do something, and you might even notice here that ReSharper is tugging at my sleeve, saying, "Hey, boss, hey, I got a good idea." And that's because it tends towards more functional code if you follow all of ReSharper's suggestions, because the functional... Oh, and also, incidentally, if anyone recognizes these titles here, you're automatically my friend, because those are the story titles in the very first series of Doctor Who from 1963. There may be references to Doctor Who in this talk, just warning you, because Doctor Who is cool. But anyway, what would this look like functionally? Like that. Now try explaining that in 5 seconds, and it gets an awful lot easier, doesn't it? And if at this point anyone's going to say, that looks like an awful lot of Linq, that's because that's an awful lot of Linq. I'll let you in on a little secret. Linq is functional. Linq is entirely based around the functional paradigm. If you're using Linq, you are doing functional programming. If you think about it, a select statement does not change the original whatever was there before, the original enumerable. It creates a new one based on the old one. So it is enabling you to immutably create an array. These here, higher order functions. you're passing functions in as parameters, again, based in the functional paradigm. So my goal is to effectively put the whole rest of C# into Linq. And that's roughly the approach I'm going for. But note also, first off, this is a lot more concise. It's easier to say what it does. And this more closely matches logically what I want to do in the order that I want to do these things logically. This is not actually the order of operations that you see here. Enumerables will execute in the order they feel that they wish to at the time, and may not even execute at all, but none of that really is your concern. All you're doing is describing what you want in the order you want it, as if you were describing it to another human being. And that's fundamentally, I think, a good thing, because if you were fresh to programming and you were presented with this or this, which one are you going to be able to understand quicker? I'd say this one. Are we? Oh, are we? No, stop. Oh, right. There's another bit of very non-functional code. This is something that I had to deal with an awful lot back when I worked for HMRC. You are very welcome. This is the rules for validating a Nino. Does anyone happen to know what a Nino is? It's something I had to be very familiar with at the time. It's a national insurance number. And there are a set of rather esoteric rules for deciding whether it's a good Nino or not. And it's all to do with which letters exist in which places, is it an alphanumeric, and so on. There's a whole load of them. And there's a big heap of code structure here, and a lot of repeated code structure. So we've got check each rule. If the rules doesn't match, then we'll return false. If this rule doesn't match, we're going to return false. Eventually, at the bottom, it's slightly missing off the bottom of the screen there, we'll do a return true at the end. Or we could do something like this. So this is something you can do, and I see some people do it, but most of the people don't. You can actually put func delegates, that is, your arrow functions, in arrays. It's possible. And not only that, but then you can apply Linq functions to them. So, and there we go. So this is an array of funcs. So that's actually, they're all described at the top here. You don't have to put them in separately, but I like the descriptive name. There's nothing wrong with that. That's a matter of choice. These are all turned string to bool. So take a string, return a bool, meaning give me the Nino. Based on the Nino, I will therefore decide whether it is good or not in a Boolean. And here I am calling a Linq all. Now what all does is run whatever's inside here. Now what I'm actually doing here is take the Nino and pass it into the function and then return its result, which is true or false. The rule of the all is that every single one of these, whatever happens in here, must return true. If a single one of them doesn't, then stop at that point. Don't bother to execute the rest and just return out early, which is a precise replica of the code on the previous page, only I'm doing it in this much code. Oh, and you can even take it a step further and do something like this. Now, some people are down on extension methods. I'm not. I like them quite a lot. They have their places. Just don't be putting any business logic in there. That way madness lies. But there we go. So I've extended it to T being everything, because it's a generic, so it applies to everything. And then based on that T, I'm also taking a params of whatever that was into a bool. And it's params just so I don't have to bother instantiating a new array every time, because I'm just too lazy for that. And then we'll call out all there. There we go. So that means that with this teeny tiny little extension method up here, we now have a function called validate, which hangs off everything. And then you could pass it a series of rules, one after the other, and that will tell you whether that thing was valid or not according to all your rules. So again, nice and concise and descriptive. You could even show that to your non-technical boss, and the chances are they would understand what it does, even if they couldn't necessarily maintain it themselves. Here's another example of a functional structure. This, I'm calling it alt here. I've seen it have other names. This is a common theme I found when I've been digging deeper into this, is that there is no great big bumper, every kid's book of functional programming, which gives you literally the definitions of what everything is and what it's called. It may exist, but it's probably a maths paper, in which case I won't read it. But a lot of these things have other names. So the names I use here, you might find the same exact concepts used elsewhere with a different name. So just be aware of that. But I'm calling it alt. And the idea is that I've got two functions which go away and get a thing. String to string, in my case, it could be anything. Now, maybe these represent two different data sources. Maybe one of them's a database. Maybe one of them's a web API. It doesn't really matter. They're actually just funcs for the purposes of the demonstration, but you get the idea. And in my case, one of them works and one of them doesn't. Now, in object-oriented code, you would need to, and you would try two different alternative data sources, then you would have to put an if in there, you'd have to do a null check, and so on. But here, with my alt, all I do is say, here's one item, here's the other item, try these one after the other, and then the first one that works, you return that. I think the TSQL equivalent is coalesce? I think it's coalesce. And there we go. That's an awful lot of code I don't need to write. In this case, this one does not return, it's a null. And if I run this code, then this one will be tried, it will find null, it will try this one, and this string will actually be a this works with my name appended on the end. Now, how does that work under the surface? Well, it looks like that. So, a couple of extension methods. They're a little messy looking, but that's fine. The thing about extension methods is they are a block of code that I just want to write the once and then never care about again. They are like the proverbial snarf action figure from Thundercats in the 1980s. I have it. I don't necessarily want anyone to see it, but I have it. Actually, I don't. I'm lying. I was never cool enough to have a snarf. But, right, what are we doing here? So, attach again to a generic, meaning it attaches to everything, and then run function 1. I've got another extension method, which is if default do, which means it assesses the result of this. If it's default, I can't say null because we're dealing with generics, and not everything defaults to null. Integers default to 0, booleans default to false, and so on. There may be others. And then here's the alternative. What it means is, if this returns default, then do this. Otherwise, just return the original, and down here, this is the default do, which takes the this, takes the function, and takes the alternative input, and it decides this is a slightly scary bit of code, which is just a generic version of a null check, because again, you can't do a null check on a generic, and what it will do is just assess whatever this is. If it's null, then run the function. If it is not null, then simply just return the value itself. It's like a gatekeeper function sitting between you and the outside world, and it's sort of, you're trying to pass, and it will stand in the way or not, depending on what you're carrying. Now, this is a ridiculously simple example, but I just wanted to keep the example simple. And all I'm trying to do is for some reason, create and count of all the A's, the B's, and the C's in that string up the top there. I could have done all sorts of things, but I went with simple because I like simple. This is a fork. Once again, I've heard these called a few things, like myself. And what it will do is start with a value, and then it'll split off into a series of prongs, as it were, of the fork. Each prong will act on the original in complete isolation, and then a further function will glue all of the prongs back together into a single result. So in my case, I'm starting with a string, and then I'm forking. This is the joining function, which is a simple sum. And here I am going count all the A's, count all the B's. So what I'm going to end up with, in fact, is start with a string, convert that to an array of integers via these three functions here, which will be executed separately on the same input, and then finally take that array of integers and turn it into a sum. And yeah, sure, it's a 9. And that's what that looks like. Again, little extension method. Attached to everything, and this is, oh, yeah, that's map. Now, that's just to be clear, that is not the same as map in AutoMapper. This is like map in, I think it's the way JavaScript uses map, which is like select, but it's not like select, okay? This is, for some reason, this is weirdly easy to get mistaken on, but map doesn't act like select in that it turns one thing into another thing, but select acts on each element of an array separately. Map acts on the whole thing. So you can call map on a string, and then this this function will turn string into whatever else you want. If you fed map an array, then this would be an array or an enumerable or whatever. It's the whole object, not individual elements of it. So it's one of those funky little helper functions that I find ever so useful. Actually, no, map, I think, in the JavaScript world is more like a select, so not like JavaScript. And all it does is convert one thing to another. And I just find it saves me a lot of space because I don't need an intermediate variable to store it in or anything. I can just do this. Just .map, convert it to something else. And so this is my fork, though. Start with the input, whatever that might be. And there's the prongs, which are my functions, and my join function. So prongs.select, bit of Linq there. So, and then inside the select, what I'm saying is, for each prong, give it this, whatever the original this is, and return that result, which will give us an array of whatevers, and then call map to say, turn that array into something. So this is a join function, which takes an array of whatevers and turns it into a final single result. That took me ages to explain, but it doesn't take an awful lot of time to write one of these things. Oh, I'm not sure if I need to entirely go into this in too much detail these days, because this talk is a few years old now, so this has become fairly common in the C# world now. But just in case, here it is. So some pattern recognition, it's a pattern matching. I'm always doing that. Let's start with bank accounts, since that seems to be the go-to example of how to do these sorts of things. We'll have a standard bank account. I'll inherit off that with a super-duper bank account, which has got a bonus interest rate, and a dodgy bank account, which has got a brown paper bag stuffed with money, probably handed over in a car park for some reason. When I started this, I usually inserted a reference to whichever politician was in disgrace these days. At the moment, take your pick, plenty to choose from. It's just not even worth it. It's like shooting, was it fish in a barrel these days? Okay. And there we go, pattern matching. I don't know if everyone's familiar with this stuff now, but you can now switch based on the actual type of an object which has many subtypes. So this BA is actually the base type, which is bank account, and then under that, I'm switching based on it's a dodgy bank account, and then here it'll if it's actually a dodgy bank account, it will automatically wrap it into the correct type, and this variable here can be referenced inside the switch to the right type. So imagine just how much code you'd have to write in order to do that if I didn't use this structure. It would be quite a lot, and it might well use reflection. So this alone is saving us a colossal amount of effort. And yeah, you can go a lot further these days. I think this is fairly up to date. I don't have a slide on list matching, which is the very latest thing, but now you can do all these sorts of funky switches where you can like switch on properties like this in this sort of JSON format, and you can really go quite complicated with these sorts of things. It's astonishing just how much code you can write with this, and this is entirely comes from the functional world. That's what's inspired all of this. So on the subject of immutability, can we actually have immutability in C#? Well, here's a few demonstrations. This pretty much is immutable. I've got gets and no sets. These days, actually, you can do init as well. Init instead of set, and that'll pretty much do the same thing. Init meaning you can set this property when you instantiate the object, and then you can't change it again, which is typically what I tend to do. And fine. We're not allowing these to be set from the outside world, and we are forcing this to come in the constructor. So that's immutable. That's good. How about now? Is that immutable? See, I'm not letting anyone change them. I'm forcing it to be done in the constructor. Is this immutable? No, it's not. That's a list. Lists. I can't replace the list with another list, but I can still add and remove and mess around with the list because that's lists. So I could go and make it an immutable array. Woo! Now it's immutable. Super duper. You can pass a list in all you like, but nope, I am making an immutable array, so tough luck. Now it's not. So that's good. What about now? Subclass. I don't even know what's in subclass. I just made it up, that's why. But in any case, is this immutable? I don't even know. And there's the problem. I don't know. If every single class in your whole code base was coded based on this approach, sure-ish. But then as soon as you try and throw in something that's come out of NuGet, some sort of third-party coding structure, it all goes out the window. Because once again, we return to, I don't even know. So this is one of my more controversial opinions on this subject. I think immutability in C# is a pipe dream. I mean, fundamentally, they're not going to change the language so that we can't support everything going backwards. They want it to be so that pretty much any older code always tends to run in the new environment. So they're not just going to make a change that will just suddenly make everything immutable, because it'll break half of the code in the world, probably more than that. So my approach is just pretend, which seems absurd, but you'd be surprised how much good code you can write that way. Just pretend everything is immutable. Write code as if that were true. Now, it is unfortunate you can't enforce it, but that's just the way it is. This is C#. It is always going to support multiple paradigms. That's not going to change. They're not going to drop support for object-oriented coding. So we just have to do the best we can. And yeah, you can put stuff like this in where you can have compiler warnings like your nullable enable. That's pretty good. But, that's nice. I do enable that. But once again, it's only a compiler warning. At least the last time I looked it was. I don't think it'll actually break the code. And if you want to override it, you can put an exclamation. Where is it? Oh, there somewhere. There we go. Yeah, where did I put it? I've lost it. But there's an exclamation in there somewhere. There it is. There it is. Yeah, the exclamation is there to say, yes, I'm a grown-up. Yes, I know. Do it anyway. Which does exist in some functional languages as well. I think F#, everything is immutable by default, but you can make mutable types, but you have to specifically create. So, that's not an entirely wrong thing to do. But, this is nice. But honestly, I find the just pretend approach works an awful lot better. And you can enable it globally like that. Oh, we can tell this how old this talk is now. Right. Class. Oh, yes. So, yes, there's the init type. I've already mentioned that. Init. I do use that quite a lot. I find that quite handy. That's the closest I get to actually enforcing immutability. So it just means that I can just instantiate a new object like this. And then if I try to change one of those properties later to something else, that actually will break it. That'll actually cause a compiler error and it won't even build. So that I use. I would recommend using that pretty widely. There we go. And records. I don't know if everyone's familiar with records now. Records are one of my favorite things since the other favorite things that they introduced. But since Linq and pattern matching, records is my other favorite thing. That is, again, something that has come around to help support the functional paradigm because it enables you to easily create a new object from an old one, which is exactly what we tend to use. In the non-record world, when writing an update function, we wouldn't update the object. We would literally create a new one, copy over each and every property, one after the other, and records just allows us to skip all of that. Because now with records, you can just say with, tell it what the one change that you want to make is, and then you'll get a new object back with just that type. Now, I believe as of now, this is actually still a reference type, but I believe there are changes coming in to allow it to be a pass-by value as well. But I'm not quite sure where we are on that. This, as it happens, is just a silly bit of code to tell me which property of this you want to update, and then give me a new one with the one changed property and maybe a bit of parsing or whatever as appropriate. So currying. I did say I would talk about currying, and here it is. Currying. Nothing to do with delicious, delicious Indian food, sadly. But, right, this is a hypothetical example of currying, sort of. That's just a normal arrow function, an add A plus B. So if I give it 10 and 20, I get back 30. Simple. At least one of my daughters could manage this. Mentioning no names, Katie. But what if it was a curried function? What if, by waving my magic wand, I could make currying a thing that happened by default in C#, which it doesn't. It does in F#, not in C#. So let's but imagine for a moment. I have just given it one parameter. The function requires two. Does anyone happen to know what will happen if this is a curried function? Anyone want to take a guess? Okay, well, there is a rule of thumb in functional programming. If there is a question, the answer's functions. And that roughly holds true. So if a curried function, you pass in one of the parameters of 2, what you'll get back is, there we go, what you'll get back is a function. And the function will be equivalent to the original function, excepting that everywhere where parameter 1 was referenced is now replaced with the actual value that you gave. So when I have an add with two parameters, and I give it 1, effectively what I've turned it into is an add 10 function. So now this is still an add, but the 1 property has been replaced simply with 10. That's what currying is. Strictly speaking, this is true currying. Never mind. There's also partial application where, so currying, true currying is where you do the functions one after the other. So if you have 5 parameters, then you'd have to like curry it about 5 times to actually get a result out. There's also partial application where you can just apply them in clusters, like, I'll do 2 parameters, then 3. But frankly, I'm blurring the lines horribly because I'm not really interested enough to go to the purity of some of these definitions. But anyway, can we do this in C# is probably the question that's occurring to folks now. The answer is, well, the short answer is no-ish. The long answer is yes, kind of. First off, currying is actually quite easy. That looks like this. Now, note that there are 2 arrows in each of these. Okay, arrow 1, arrow 2. There are 2 arrows. These are arrow functions that return another arrow function. So yes, this is currying. Does this have uses? Some. I sometimes throw things like this together to kind of save myself a little bit of code noise, or maybe to make something look a bit more descriptive when I'm putting together a big chain of functions, something like that. This has its uses. But unlike in the F# world, we can't just arbitrarily then go and apply both parameters. We've got to strictly do them in order. There is an alternative. That's more like what we would call partial application, which is roughly the same concept. So this, once again, returning to Doctor Who, I told you it might be back again. Yay. This is a really generic version and of a rather crude parser for a CSV. We're split by line first, split again by field. So by line will be new line, by field will be a comma, like you see there. Maybe do some trimming and selecting, and then of the array of arrays, we'll then go through the whole lot and return one of the fields from it. Okay, so that's doing an awful lot of stuff. That's a fairly complicated little function, and I'm going to pass in 3 parameters to make it happen: a string, a char, and an int. If I wanted to do partial application, I could use it like this. So I'm using an extension method, I'll show you in a minute, called apply. So apply means give me back a function which is the equivalent of the original, but with these parameters filled in. So that is my currying, my partial application. So first off, start with the original function and apply new line and comma. So what I've now got here is something which will take a CSV content, it will split it by line, it will split it by column, and then it still requires you to tell me, first off, which field do you want, and then actually give me the string, because I don't have it yet. Then I could call it again. I could partially apply this one and say, I want the 0th field, which is the story code, because every Doctor Who story has a story code. So what I've now got is a function which takes a string, which is a CSV, and then does all of that business. It splits it, and then gets the 0th item. And here we can call the parse here and differently apply it, give it a 1, which now means I've got something that will take the CSV, split it, give me the story title. So I've created 2 different functions with an awful lot of functionality, but I've actually only written 1 function. There's still only 1 parse function. Everything else is just kind of a functional equivalent of trying to give it many ways to be used, kind of like trying to turn it into different shapes to go in the different holes, as it were. Now, how do you actually do this? It's pretty ugly, not going to lie, but that's how you do it. So once again, if you were to use this is something you shove to the back of your code base and try really hard to forget. But this is roughly what it's done. Again, 2 arrows, arrow, arrow. This is an arrow function returning another arrow function. And it is taking the original arrow function. Now, it'll only be possible to apply this to funcs because you cannot hang a function called can't have an extension method in C#. So that's one limitation. You'll have to take your function and store it in a func somewhere. And then having done that, we call this, and it returns the new function with some of the parameters coming from the new arrow that you're creating and some coming from the original call, which stays sort of stored in memory as a reference until such time as you actually collapse this into a value. And the other problem here is you have to create one of these for every combination of variables going out to variables coming in. So you might have to write a lot of these. None of them are terribly complicated. This won't take a lot of time to do, but you'll have to create one version of this for everything. 5 to 1, 5 to 2, 5 to 3, and so on. So, okay. So this is a typical flow in a functional function. Start with one thing. First opportunity you get, split it into a list of things of some description. This is why Lisp had its name. It was it list processing language, because functional works best when you have turned something into an array, else, whatever, and you are applying list-based operations to it. Maybe do some wearing, maybe do some selecting to turn it into a different type, and then finally, this is the last bit, aggregating. Aggregating is the art of turning many things into one thing, and this is the bit that probably tends to elude a lot of folks when they're trying to move when they're trying to move away from the object-oriented approaches. Well, we have a whole load built into C# already. This is an example of what you would do in the old object-oriented world to aggregate something. You'd maybe I'll put a string builder in because I've been doing this for a bit. I know about the don't append strings in a loop thing. If you don't know about that, ask a friend. And I'll loop around, append lines. I also need to put an if in there to say, well, if it's the last one, don't append a comma to, and then eventually we'll get a list of all the story titles with a comma, excepting on the last one, and some new lines. So super. That's object-oriented code. That's the functional version. Yeah, I'm being a little facetious here. String.join. If you don't know about string.join, use it today. It's brilliant. It's one of my favorite functions in the whole of C#. But yeah, it gets around that problem of what do you do with the last item, because this does all that for you. But you get the idea. That is an example of aggregation. But yeah, the slightly more grown-up version of it. So let's take a list of, these are objects representing Doctor Who stories. So I've got my code, my title, my rating, that's my personal rating of whether I liked it or not. First Dalek story is good, the censor writes is terrible, and you get the idea. Number of episodes, because in the old days Doctor Who was all serials, many episodes per story, and then number of missing episodes, because there are, to date, 97 missing episodes. If any of you have them, I'd be awfully grateful if you'd hand them over, especially if it's Fury from the Deep. I'd quite like to see that one. But anyway, and I want to put some sort of report together of comparing, say, number of episodes to number of missing episodes per season. Now, of course, there's sums. Sum is another form of aggregation that exists. That's a Linq method. Sum is good. There's average, which calls it average. I think it's actually a mean, because there are like 3 kinds of averages or something like that. But fine, it exists. I don't think there's a way to do medians easily in C#. But this is the grown-up version. Aggregate. I am astonished by how many people don't know this exists, but it's been in C# since a very, very long time. It seems to be one of those great unknown things of C# almost, and I will carry on talking about it until people tell me that this is old stuff now, but this is brilliant. Aggregate is incredible. I use it a lot, and what it means is it's not unlike a select statement in that we apply it to an array, or an enumerable rather, and it'll apply to each item in it separately. But here we start with a starting state. Now I'm using a tuple of 0, 0, meaning the number of missing episodes in here and the number of actual episodes here, and then you give it a function after that. The function is, this is the running total so far, and this is the current item. This is like your X in an actual select statement. And this lot is, give me a new running total based on the old running total and the current item. And then it'll apply that to every item in the entire enumerable. And then finally, what you'll get is literally just whatever the final version of this is. So the first time this runs, it'll be 0, 0. So we'll go into here, that's 0, 0. That's the current item, which is unearthly child, 4 episodes, non-missing. So this will be 0, and this will be 4. So this will return a new tuple of 4, 0. Then it'll execute again, and it'll be the Daleks, 7 episodes, non-missing. Which the current, then this will be 4, 0, because it's already run once. This will be 7, 0. You get the idea, and so on and so forth, all the way to the end. This is, I think, the last item I'm going to introduce to you. So this is something that I used to do quite a lot when I worked for an American company. I'm British, as you can probably tell, and as you guys probably mostly know, we do indeed talk about the weather an awful lot. It is a thing that we do. And I would ask my American colleagues what the weather is like, and they would say that the temperature is 100 degrees outside. And I think 100 degrees, that's the boiling point of water. My goodness, that sounds quite serious. But of course, they're talking Fahrenheit, which is used by America. And I use Celsius, which is used by everyone else. So the conversion is deduct 32 multiplied by 5 divided by 9, something of that sort. Of course it is. So, but my point is I've got a series of operations here. Start with a thing, do a thing, get the new value, do another thing, get a new value, do another thing. Yeah. It's like a relay race of operations, one after the other. Now I could store these intermediate variables if I wanted to make this more functional, and that's great, but then I've created all these intermediate variables. And before anyone points out, yes, you could all just put this in one great big line, but then I would have no demonstration. So imagine swapping these out for some more complex operations. I am keeping life simple by giving you this example. But how could I do this in a much better way? Well, this is an object called identity here. I've heard this called a few things. It's an identity of type T. This is a class. And here we go. It's got one property, which is simply value. You can put a bit of syntactic sugar in here so you can just turn things into an identity or not. Or, to be honest, I often just create extension methods. And that's fine. Think of identity as thing in a box. Thing in a box. That's all it is. It's a box, got a thing. And it's a T, so it could be anything. I don't know what. It doesn't matter. But it's a thing in a box. And there we go. There's my extension method. And I'll create a function hanging off it called bind. Heard this called a few things too, but bind is as good as anything for now. And this is not unlike my map function from earlier. And what this does is take a function which turns old thing to new thing. Most of the time in that previous example, I think it'd be decimals to decimals, but it could be decimal to string, or who knows what. It doesn't really matter, but thing to thing. And so what this function does is take the old box, pull the thing out, do a thing to it, pop it in the new box, send it off. And then the next guy will do the exact same thing. It's a relay race of functions. Each person takes the old item, does a thing, passes it on. And each time it's a new box with the old one effectively chucked away the moment it was done. Because everything is transitive in function. And then I can end up with something like this. Now look, there's my curried functions. They're back. See, they have their uses. And so that looks pretty good. No intermediate variables. Everything is immutable. Each of those values exists for a moment and it's chucked away, so that's great. Technically, this will probably maybe have some savings if one of those was a large complex object because it's basically chucked away the moment you've used it. That's great. So this is a simple example of what's called a monad. In case anyone ever felt they didn't know what they were, there they are. Don't be looking them up on Wikipedia, by the way. The technical definitions are really quite terrifying. I've been doing this for years, and even I don't understand the technical definitions. But you want to know what a monad is? Relay race. Take a thing, do a thing, pass it on. That's it. It's a way of chaining functions. There's a bit more to it, but this is good enough. I'm an engineer. I need an engineer's description. So there is another form of monad because there's a load of different monads for different purposes. There's loads of them. I only use probably 2 or 3 because that's all I need, at least in the C# world. Haskell's got a ton, but I don't use Haskell. I am a C# developer. But this one's maybe. Now, this is similar to my previous one, the identity one, but there's a difference. Okay? There's a difference. First, this deals with the problem of what if something explodes? What if there's an error? Stuff like that. It deals with that problem for you. So we've got some sort of getPerson function here. which goes away, maybe it does a database operation, doesn't really matter. And what if that returns null? Well, if that returns null, then under the existing system, this will just explode because null reference exception, the so-called, was it, $1 million mistake. I don't want that to explode. I want that to be handled. I want the bind function to be smart and handle that problem. I want each little bind to be like a safe environment to run the function but not be affected by it. So, there. So, this is another one of those places where I know about dozen names for this particular structure, but I'm making an abstract class called maybe. Again, it's of type T, and it's got a value, meaning I've got a thing in a box. It's just the same. And I'll inherit off it twice. Once as just, I've also heard this called sum. Maybe I've also heard called option, so you may hear different names. And this means it works. There was a thing. The thing was taken in, the function was executed, something was returned out. It was good. And this is nothing, meaning it didn't work. It errored, or a null came back, or something. But the point is that if it's a nothing, it is a nothing. And I'm just going to replace that with a default. And there's my more complicated bind. So now I'll do a switch to say, OK, look at the item you've just handed me. Did it actually contain something? As in, was it a just or a something or whatever? Was it not null? If it was something and it was not null, in that case, run the new function and then take the result, put it in a new maybe box and send it on its way. All other circumstances result in just, I ain't going to do a thing, I'm just going to return a nothing. And if anything fails, it'll also return a nothing, if the catch catches. The best analogy to this I've ever read was on Scott Blashin's website. It's a very good website, F# Fun and Profit. It's not just for F# developers. There's a lot of good theory articles on there too. But he called it railway-orientated architecture, I believe. And so the idea is that you've got two railway tracks running along like this, and there's a set of points. Each point is a function, and then it'll execute each function. And the top track is the something, the happy path. And if at any point something fails, you switch tracks and then just glide to the end without doing another thing. So if I just, there we go, if I blast back to this, so in my example here, so this is now a maybe. This bind will check the inside of the maybe. It's something, it is a person ID, 12, whatever 12 means. And it'll, then fair enough, I will execute that function. Now, the person 2, maybe it's a null, or maybe it throws an error. Who knows? It doesn't matter, but the point is it doesn't work. In which case, you'll get a nothing back. So this bind executes, it has a look inside the box, and it says, actually, the type of this is a nothing. I'm not going to do it. So this function here is not executed, nor any of these. What I get back is a null. The last function that was executed was this one. So the whole concept of worrying about null checks and try catches goes away. It's now baked into the structure of this bind and maybe system. So basically, no more errors anymore, in theory. I mean, you could probably find new and creative ways to add them in, but it is an awful lot harder. You've got to work for your errors. This is an alternative. It's called either. Again, I've heard a few names, but it has a right and a left. That's how it's usually defined. The right is the happy path, the right hand of justice or whatever, and the left hand of darkness, the left hand of evil, as it often is in many cultures, is where it didn't work. So in my case, I'm just giving it radically different things. So I'm saying there's a value here, and here there's a nothing, a default, and I'm actually capturing the exception. So in the case of this one, when I get to the end of my chain of functions, I can examine it, and then not only do I have a check already baked in to say, did it work or not, but if it didn't, I'll actually catch the exception, and I can display that to screen or log it or whatever I need to do. But I haven't actually broken the order of operations. And there's you've slightly modified to either. Now, in production, to be honest, I tend to merge these two together. So I create like a 3-state monad, which isn't exactly strict functional theory, but it works for me. So I have like something, nothing, error, because those are the 3 states I tend to always need to check after every operation. Did it work? Did I get something? Did it throw an error? And that means I just do a switch operation afterwards to collapse that possible 3-state thing into a 1-state thing. It's like Schrödinger's object. You get this box. There might be a dead cat or it might not be a dead cat, but you can check. But only at the moment you check does it matter. Otherwise, you can simply pass it on without opening it. So, are there any libraries which exist in NuGet for doing functional? Yes, there are. LanguageX is probably the largest and most mature of all of them. LanguageX is a good one if you want to. Now, personally, I don't use it. It's not because it's not good. I think it is good. But I think that it's so simple to write your own that largely that's what I do. And also it's good for learning the theory, which again is what I like to do. So I can personalize it to exactly my taste. But if you just want to use LanguageX, go for it. More power to you. There is nothing wrong with it. There are others, but this is the main one probably. And that's what the LanguageX version of my monad looks like. It calls it map instead of bind. Well, strictly speaking, map and bind are different things, which they actually respect inside LanguageX. I kind of ignore the difference. But I'm not going too deep into theory. Finally, further material. There is an excellent book by Enrico Buonanno, published by Manning. It's in the 2nd edition now. This is an excellent book. That's functional programming in C#. That was one of the things that put me down this path originally. There is one by Pacts by, I hope I'm saying this right, Vishnu Angoro. One day he'll be in the audience and be like chucking stuff at me. No, it's not how you say my name. But I hope it's not too bad. But that's pretty good. Although I like the Buonanno book is really quite excellent. There is a talk which is actually the first introduction I ever got to functional programming by Kathleen Dollard. That was done at NDC Oslo many years ago. It's still on YouTube. If you were to be able to do magic and turn the camera around on that video, you'd see me gawping with awe at the nice talk. There are a couple of Pluralsight talks. There is Scott Blashin's website, which I do recommend, even if you don't plan to do F# and then learn your Haskell for great good. I mean, yes, if you want to go all the way, you can pick up Haskell. And also, there's my book. I have a book. Yay, my book. It's not quite probably not as in-depth and pure to the functional paradigm as the Buonanno book is, which is an excellent book still. I'm more the silly fun uncle of the programming world, and it is full of terrible dad jokes, I'm just warning you. I keep expecting the editors to take them out and they're not doing it, so I'll keep putting them in. So that is not incidentally my animal. I don't know what the animal's going to be. Apparently there is a secret cabal of animal choosers somewhere deep in the dark depths of O'Reilly, and they will descend from on high when it's publication day, and then I will know my animal. And knowing my luck, it'll probably be something repulsive like a naked mole rat or something. But I will cope with whatever I get. This barcode, by the way, O'Reilly gave me that. It'll give you, I think, some months free on their website. So the pre-release version is available. There's 9 chapters of the book, I think, available on there at present. I'm currently writing chapter 13, so yeah, it's thought to be coming out probably in the summer. Although probably the only people that ever buy it will be like my parents and anyone that I give a £20 note to take a copy from me. But still, if you're interested, there's my book. I can take a short breathe. Does anyone have any questions at this point? Awed silence. Not sure if good or bad.
I'm a little bit curious how you deal with memory management.
Okay, memory management. You're curious about how I deal with memory management. Okay, so there is a widely held opinion that functional programming is not good on memory management. It tends to use more memory. That in and of itself is true. Functional programming does use more memory compared to object-oriented alternatives. If memory usage and speed are your absolute main 100% priority, you probably don't want to do this. But because, object-oriented code is always going to be slightly faster and slightly more memory efficient, generally speaking. But the difference isn't that much most of the time. I've done a whole load of checks, and if you compare how long a function runs object-oriented compared to functional, it's like there's a bit of difference, but then you throw in something like a file read, it's like this much difference. So the difference, for most cases, is insignificant compared to the problems of read a file or go away and do an HTTP request.
But I'm wondering, for example, in Python, when you deal with very very large amounts of data, you can use like generators. So you'll used to have like a little piece of memory at a time.
Okay, with Python you have generators, and I'm afraid I'm not familiar with those.
Like it's kind of like lazy, like a little bit.
Okay, lazy. Okay, well, effectively, okay, it's going to instantiate something in a lazy manner. Well, we can't. I mean, enumerables have that, of course. Enumerables are lazy. I'm not sure how much else we can do in the. I mean, we are still constrained by the limits of the C# language. So on this, I'm going to have to plead ignorance. But the only thing I would say though is avoid recursion. I do joke about recursion, but yeah, it's not a joke. That stuff's horrible. It'll explode fast in the C# world, but F# you can actually do recursion safely. It has something in place, which if you look in the intermediate languages, a hidden while loop. But basically, but no, I'm afraid I wish I could provide you with more than that. But no, I don't know. I'll look into generators and maybe I'll write something up on that. Sure. Yeah. Does anyone else have any further questions? Oh, I have two. Sir.
I noticed you were using XUnit. Is that more friendly for functional?
No, XUnit. So I was using XUnit. Yes, no, not particularly. I just like it. I just happen to like XUnit. That's just a preference. I also quite like fluent expressions, the fluent assertions. Sorry, fluent assertions. Just like it. It looks friendly.
Yeah.
No, it's got nothing to do with functional or not functional. That's just what I like to use. Sir.
Where do you sort of strike the balance between, like, in terms of functional, how much you can use coalescing versus going full monads?
Okay, how much are you saying about a null coalescing? So how do I balance null coalescing with full monads? Well, this is where you get more into the art than the science of these things. But if it's really simple, then I'd probably just throw a quick null coalesce. If there's any number of operations whatsoever, full monads it is. I have a little bit of a preference, to be honest, for literally writing everything as an arrow function and never putting a body on any function ever. But probably people at my work would just throw things at me if I tried doing that. So go and have a look at my answers to the advent of code if you want to see me going all 100% as far as I can go. But yeah, that's my rough rule of thumb. It's simple null coalesce, more than that, monads it is. Or if there's any possibility of an exception happening. If there's a chance it might throw, then we're going back into the monad, because the monad's like a nice safe environment to let things explode, isn't it? So if I'm doing a database operation, and usually most of my return types in my on my any database operations is actually usually maybe of whatever it is, maybe of a new. It gets awful when you get into async. It's like may task of maybe of IEnumerable of donkeys or whatever. But still, it does. We all know what that does. It's sort of unwrap. You have to unwrap them one at a time, though. But any more for any more? Going once. Go. Oh, there we.
Container monads like in data production other than identity.
Do I use any other container monads? In fact, as I say, I actually use one which is kind of a mix of maybe and option, or either. So mine has three states, as I say, the something, the nothing, and the error, which is not strict functional paradigm correct, but it works, and it does everything I want to do. So by and large, I use that. I have been known to use a reader, but I don't even use that very often, to be honest. Largely, and a state monad, I've used those once or twice. Largely, though, my funky jury-rigged three-state monad is the one I use. So I got all that in the book if you're interested. Or have a chat with me afterwards. But yeah. Any more for any more? Sir?
Validations. People use that.
The fluent, the validation, put your mind to fluent validations, would I recommend that? I haven't actually used that myself, but I think it's the same guys that use fluent assertions, and I know people who use that and love it. I actually know, before they brought that out, I actually had a colleague who wanted to use fluent assertions in production code, because he loved it that much, until everyone started throwing their shoes at him. But yes, I definitely would. I probably should pick that up myself, and that's probably just sheer laziness that I haven't. But yeah, absolutely, fluent assertions is lovely. And by extension also, we're starting to lose people now, but I'm still happy to take questions. Has anyone else got any questions? Going once. Going twice. Done. Solved. Thank you very much.